Hey everyone, welcome back to my Calculus 1 series. In today's lesson we're going to be talking about indefinite integrals. So in the previous lesson we went over the definite integral. And we saw that it's written as this, in this form, that the integral from a to b of f of x dx, and then we would evaluate it to some sort of number. Essentially we learned that in the fundamental theorem of calculus 2, it states that this is what it will evaluate to. Since today we're going to be learning about indefinite integrals, it's important to differentiate the two, the definite integral versus the indefinite integral. So the definite integral, its key characteristics are kind of its bounds. The second we see these bounds, we know that we're dealing with a definite integral. It is defined on some sort of interval, whereas we'll see with the indefinite integral it won't be. And the next key distinction to make is that the answer, this right here, will actually evaluate to a number. The answer that we get from evaluating this integral will be a number. Onto the indefinite integral, it looks pretty much the same as a definite integral. However, like I mentioned, we just don't have these bounds anymore. That's all that's different. So the key distinctions to make here is that we have no bounds, and that when we evaluate this integral, it will evaluate to a family of functions. So before we saw that this would evaluate to this stuff here. However, with the indefinite integral, we won't get a number anymore. We're just going to get the antiderivative and then plus a constant, like we talked about, because the derivative of a constant is 0, so we can always include this constant. So we will just get these family of functions, and that's all the indefinite integral is going to tell us. So as for evaluating indefinite integrals, because when we evaluate it, it's going to equal to a antiderivative, it's important to go over our antiderivatives and kind of just remember what they are. So I'm going to write out a whole bunch of them. Feel free to pause the video if you are kind of confused by one, but I'm not going to be going over them. It's just like a big set of them, and essentially either memorize them or I don't know if you want to work through them, but generally most people just kind of memorize them and then they know them. So here they are. Here is a bunch of them. I'm going to zoom out so hopefully you can see them all. Again, feel free to pause the video. Just the key thing to note is that for all of them we're going to be including this plus c, because this constant we're going to carry everywhere in the indefinite integral. So yeah, here's a big table of them. Memorize them or remember them somehow, and you'll be okay for evaluating indefinite integrals. So now moving on to an example, we're just going to see how we can apply everything that we've learned about integrals. Again, there's not much to indefinite integrals that changes from definite integrals apart from just in evaluating to a family of functions and having no bounds. We've learned a good chunk about integrals already. We've learned about the properties, and you've just seen the common antiderivatives that you can kind of count on. So we're just going to learn again how to apply that, and that'll be it for this video. So here we are given this integral and we are asked to find it. So I'm going to link back, I'm going to add a card back to my video about properties of integrals. So if you're kind of rusty on that, just feel free to go over there, quickly look over it. But essentially we're going to evaluate this using those. So firstly what I'm going to do is I'm going to kind of I'm going to split this integral up right now. So there we go. Now that we've split the integral up, we can start removing the constants, because that's one of the properties. We can move them outside of the integral. So there we go. And now within the integrals, we are left with just bare bone functions that from the table we know how to compute the integral of. So I'm going to go ahead and find them right now. And there it is. Again, let's not forget this plus c, and there we go. All that's left to do is just simplify, which will be 2x to the power of 5 minus 2 tan x, oops, and then we're just going to add c. So there you go. It was just a pretty straightforward example, just how to apply the properties that we've learned alongside the new antiderivatives. So yeah, that's basically it for this video on indefinite integrals. Again, we've learned a lot about integrals already, about the properties, and now we've learned about the kind of antiderivatives, although we have gone over that in a previous video. So yeah, not much changes apart from these, just this key distinction between the definite integral and the indefinite integral. If this video has helped you out at all, please like and comment as to what I helped you with. Like usual, if you're new to the channel, please like, comment, and subscribe. And yeah, I will catch you guys in another video.